Before we start on our notes for today, I want to look at worksheet 4-2. The first thing I need to tell you is problem number 1 has a typo. On your problem number 1, it doesn't say equals 0. You can't actually solve it unless it has an equal sign. And so would you please add in on problem number 1 that it is equal to 0. And then after you factor it, and then you solve it, down here at the bottom, you should have 2 solutions. Most, if not all, of the problems on this are called quadratic equations. They're called quadratic equations because x is squared. The biggest power of x is x squared. If x is squared, there's going to be 2 answers. On one of your examples in your notes, x was to the 3rd power, and there were 3 answers. If you have an equation and the highest power of x is x to the 4th power, how many answers do you think there will be? There will be 4 answers. And so on all of these problems, x is squared, and so there's going to be 2 answers when you get to the bottom. Now, I'm not going to go out through and work that one. I just wanted to point out the typo to you. The next one I want to look at is problem number 5. You cannot factor it, therefore you cannot solve it if it is not in standard form. If it's in standard form, what does it have to be equal to? Has to be equal to 0. Is problem number 5 equal to 0? Then we have to make it equal to 0. So what are we going to do with Mr. 48? Now, don't write this down because this is incorrect. This is 4x minus 52x equals 0. What's wrong with that? Does 48 have an x? Is it a like term with the 4? No. Now you can write this down because now I'm going to write it down correctly. I mentioned that because I saw a lot of people doing that incorrectly. Is it factored? Not at all. All I did was get it in standard form. First thing I need to do is a GCF. Does it have a GCF? The GCF is 4. X squared minus x minus 12 equals 0. And then you're going to factor it, and then you're going to solve it. I'm not going to finish this one for you. You're going to finish this one. The one I am going to work with you all the way from the beginning to the end is problem number 7. Would you please look at problem number 7? First question to ask yourself, does it equal 0? If it doesn't equal 0, you're going to have to add or subtract something to make it equal to 0. It's got to be in standard form. Second question, does it have a GCF? What is the GCF? So I'm going to factor out a 6. Then, just like I was doing for the last week and a half, I'm going to figure out the A, the B, and the C, and I'm going to multiply the A times the C, and I'm going to write down the factors of 12. After I have the factors of 12, is there a pair of factors that it can add up to my B number of 1? Would those add up to equal 1? Now, is the A equal to 1? Is the A equal to? 2, not 1. I can't use a shortcut. I have to go through the whole process of replacing x with this. I keep the negative 6 at the end. I keep this at the beginning. I replace the x with these 2 because they're equal to x. And then I make 2 groups of 2. And I factor out an x here and I factor out a 2 here. Whatever this sign is the same sign on the 2. Some people were a little confused about that. If this is positive, the 2 is positive. If this is negative, the 2 is negative. Okay, so I still have this 6 hanging around out in front. This x factors out of this and gives me 2x minus 3. This 2 factors out of this and gives me 2x minus 3. I have a double factor, and the second factor is x plus 2, and it's all equal to 0. Up to this point right here, all I have been doing is factoring the same thing I've been doing for the last week and a half. No difference. Here's where we start adding two more steps to it to actually solve it. You have to get it factored first, and then we need to solve it. Okay, so what do we have? I'm going to have to go to a different screen. My board is acting crazy today. Okay, so what did I have? I had 6 was my first factor. The zero product property says that if it's equal to 0 down there at the end, one of the factors had to be 0. The first factor was 6. The second factor was what? Because I'm on a different board. 2x minus 3. And the last one was x plus 2. One of those 3 factors or all of those 3 factors have to be equal to 0 in order to solve it. Now, is this possible? Can 6 equal to 0 in this world? Maybe some other universe, but not in ours. So now I'm down to 2 small equations. Can you solve those 2 small equations? Add 3 to both sides. Divide by 2. One of my answers down here at the bottom is 3 over 2. Down here, I'm looking for 2 x's that make the original equation true. Subtract 2 from both sides. There are my 2 solutions. So hopefully that cleared up any questions that you might have had from the work yesterday. Question? Okay, would you please look at our notes for today? Our notes for today is for the sum and difference of 2 cubes. The notes for today are on factoring again. We are not solving anything here. Again, you factor in order to solve later on down the road. But here we've gone back to just factor. And we're factoring cubes. What's a cube? What does it mean, factor cubes? Sum of 2 cubes, difference of 2 cubes. What's a cube? No? What's a cube? What power do we call a cube? Why do we call a power of 3 a cube? Well, there's a tie-in to geometry. Do you know what a cube looks like in geometry? Sorry for my terrible drawing here, even before I get started. A cube in geometry? 3-dimensional square? How do you find the volume of this? If this, all the sides were 2, the volume of this would be 2 times 2 times 2. The volume would be 2 to the 3rd power. That's the tie-in with the word cube. The volume of a cube is the side to the 3rd power, so anything raised to the 3rd power is called a cube. And we are going to be factoring these 2 special kinds of cubes, the sum of 2 cubes and the difference of two cubes. And we have a formula. See the formulas? What's the difference in the two formulas? Please fill those in on the first page. See where those go? You have this problem down there at the bottom of the first page, and we are going to compare it to this formula. And all we're going to do to factor it is every place there's an A, we're going to put an X. Every place there's a B, we're going to put a Y. That's all we have to do. And so A's changed to X's and B's changed to Y's. X. Only I forgot to change it. If you multiply this out with a box problem, if you multiply this out, if you multiply that minus x squared y, xy squared, x squared y minus xy squared y to the third power. If you multiply that out and combine like terms, what happens to those two like terms? They cancel out because they're the same term with opposite signs. What happens to those two like terms? They cancel out, and you are left with these right here. That's what it means when you factor it. It means if you multiplied these two together, you would get the original problem back. Now, we don't have time to go through each problem and check it out with a box problem, but you could. Your next problem is a difference of two cubes. Every place you have an A, you replace with an X. Every place you have a B, you replace it with a Y. You just apply the formula. All we're doing is applying the formula. We are not solving anything. We're just applying the formula. You don't have to memorize the formula. The formula will be given to you. All you have to do is see how to apply the formula. Okay, I believe this problem is on the next page. I'm not going to solve out this problem. I'm just looking at the signs. If this sign right here is a plus sign, am I using the first formula or the second formula? The first formula. In the first formula, the signs for the first formula are plus, minus, plus. If this is a minus sign, am I using the first formula or the second formula? In the second formula, it's minus, plus, plus. Everything about the two formulas is the same, except these two terms switch signs when you switch from a positive to a negative. Everything else about the formulas is the same. You see that? And once again, we're going to have to apply the formulas. Now, I'm thinking you probably don't have your cubed numbers memorized. You may know that 16 is a perfect square number. Do you know that? What's the square root of 16? 4. But you may not know 512 is a perfect cubed number. I'm thinking you probably don't. So I've put this chart up here on the board to help you out with these perfect cubed numbers. So let's see how we're going to use this chart. Okay, here's your next problem. And I'm going to get rid of that. Okay, here's your next problem. So I got to figure out, to get started, I've got to know what the A and the B are. The A and the B are the numbers that are raised to the third power. Right here, X is raised to the third power. But right here, 125 is some number raised to the third power. Is 1 times 1 times 1 125? Pick your calculator up. Is 2 times 2 times 2 125? Or 3 times 3 times 3? Or 4 times 4 times 4? What do I have to multiply by itself 3 times in order to get 125? Is 5 times 5 times 5 equal to 125? See that by using your calculator? Or we could come over here to the chart and see that 125 is 5 to the third power. That's how I made the chart. I took the 5 and raised it to the third power and got that number. Okay. So, the A is going to equal to X, and the B in the formula is going to equal to 5. The numbers before they got raised to the third power. Now, also in this formula, I have an A squared. If A is X, what's A squared? If B is 5, what is B squared? And the other thing I'm going to need for the formula is A times B multiplied together. When I multiply that together, I would have X times 5, but we don't write it in that order. We write the 5 first. So now that we have all this stuff written down, all we got to do is plug it into the formula. A is X and B is 5. Do you see that's this part right here without the third powers? A squared, and the formula tells me a negative sign comes next. AB is 5X. And B squared is 25. If I had time, I could multiply those two together, and I would come out with this as the answer to the box problem, because the X squareds would cancel out and the 5 squareds would cancel out because of the signs. Again, all we're doing is factoring. What comes after factoring? Solving. We're going to eventually solve it, but not today. By the way, this does not factor anymore. If you did your A times your C, you wouldn't be able to factor it anymore. Okay, so here's the next problem. And so this, first thing I have to do is figure out my A's and my B's. The A's and the B's are the numbers raised to the third power. Well, this is just X to the third power. 27 is what number raised to the third power? So this is 3 raised to the third power. So A is X and B is the 3. So A squared is X squared. Square both sides of this. Squared both sides of this, B squared is equal to 9. A times B is 3X. Now I have all the pieces. I'm going to go plug them back into the formula. A minus B a squared b squared minus, nope, plus the 3x in the middle. If I multiplied this out with a box problem right here, this is what I would get back for the answer, because that's what you're doing when you're factoring. Okay, we're going to skip over to this problem right here. And this problem right here. Can you find it? What is it at the top of the next page? Okay, so what was, I have to break this down into something raised to the third power, something raised to the third power. What was 125 before it got raised to the third power? And the 216? 6. Okay? So, we're going to go back over here. This is 5x. That's equal to the 125x to the third power. What was this? So, the a is 5x and the b is 6. Square both sides. A squared is equal to what? What's that when you square it? What's that when you square it? Square both sides. AB, multiply these two together. What's 5 times 6? And it also has an x, because that one has an x. Now you have all the pieces. Plug them into the formula. What formula? Well, if this is a minus sign, which formula do you use over there on the other side of the page? The first formula or the second formula? The second formula. It's going to start off with a minus b. A squared at the front, b squared at the back, a, b in the middle. Check and make sure I have the right signs. Is this supposed to be a negative sign first and then a positive sign? Because the only difference in the two formulas are these signs right here. You act like y'all have it. Okay. Look at the chart. Can you find a 343? Can you find a 125? So this right here is going to be 7x to the third power, and this is going to be 5 to the third power. Done with my chart. Now I'm going to write down all the pieces so I can put the pieces into the formula. What's the a and the b? Square both sides of this. A squared equals 49x squared. Not just the 7, not just the x. You got to square both of them. Square both of these. The other thing I need for the formula is a times b multiplied together. 7 times 5 is 35. If this is a plus sign, I'm going to use the top formula on the other page. It's going to start out with a plus b. A squared, and the b squared is going to be down here at the end, and this is going to be the AB in the middle. Check the signs. Is it plus, minus, plus? Is that the way the signs are supposed to be? Please complete. See if you can do the last one all by yourself. Did you get it right? Assignment number worksheet 4.1 will be due on Thursday. The salmon colored one, assignment 4.2, will be due tomorrow. Worksheet 4.2 is due tomorrow. Worksheet 4.1, the green one, is due on Thursday.